Okay, let's do A exam, number 3. Um, First question, find a tangent line to W at 30. Now, we are told the W of 30 is 125. So W of 30 is 125. This is A. And so we're told that W of 135 is 125. And then we're also told, oh, we can use the chart to figure out that the derivative at 30 is 0.5, right there on your chart. And so remember, that means it goes to the point, oh, sorry, 30, making a mess here. 125, and the slope is 0.5. So y minus 125 equals 0.5 x minus 30. There's our tangent line. And then I want to approximate this at 32. I mean, the chart only goes to 30, so I'm going to go to 32. So y minus 125 equals 0.5. Put 32. 32 times 2 is 2. Oh, that's not so bad, is it? Equals 126. B, use left-hand Riemann sums. So left-hand Riemann sums. So if we look at the data here, 0 is 0.6, 10 is 0.7, 22, and I know that's it's supposed to be bigger than that, but just go with me on it. 0.1 or 1.0, and then 30 is 0.5. So if you're using left-hand Riemann sums, now be careful using left-hand Riemann sums. So this one's going to be 0.6, not 0.7. This is going to be 0.7 and then 1. So 10 times 0.6, 12 times 0.7, and then 8 times 1.0. Okay, so that adds up to, I'm gonna just try to cheat here and look at the answer. Just double check, make sure I did it right. 10 times 0.6, 12 times 0.7, yeah. That adds up to 22 point, 22.4. Okay, so use the on the integral. Now, use this approximation to estimate the water in the reservoir. Now, you have to keep in mind, there already were 125 gigaliters. I have no idea what a gigaliter is. Probably a lot of water, I guess. 125 plus the 22.4. Whoa, hold on. Hold on, table. Price differential. Table gives water samples. Oh, crap. I apologize. That wasn't at time 0, that was at time 30. That was at time, oh man, they're being twits here. That was at time 30. Don't ask me why they did that, but that's, so I have to subtract to get how much time there was they don't want the time at 30, they want the time at 0. So if this is the time at 30, and this is how much water was added from 0 to 30, then we have to subtract. Sorry, I had a little brain stall there. I would have gotten this question wrong. I would have just totally read it backwards. So again, again, no one does this. You have the time at the beginning and then you have the time at the end, and you find the amount of water at the end. But they gave us the water at the end. I mean, mathematically it's not an issue, but just be aware that that was kind of a weird question. Okay, explain why there must be one time other than 10 where the derivative has to be 0.7. This is called the intermediate value theorem. Intermediate value theorem. I can't go from, when I'm at 22, I'm at 1, and then by the time I get to 30, I'm at 0.5. I can't go from 1 down to 0.5. So by the intermediate value theorem, the derivative would have to equal 0.7 on the interval 22. Don't write 1 to 5, 1 to 0.5. That would be that's the y values, or the y prime, or the w prime. But that's not on. So by the intermediate value theorem, we know it's got to equal 0.7 somewhere between 22 and 30, because this is more than 0.7 and that's less than 0.7, and I can't go from 1 to a half without passing through 0.7 somewhere on that interval. Now the D question, someone else had a question on the D question. Here's the important part of the D question, and I don't remember, somebody actually specifically asked, why do we do W prime? It's a related rate question. So the D question here, let me move back a little bit. Here is, so we have this equation here. When we take the derivative, notice that the units here are in time, okay? We were find the instantaneous rate of change of A in kilometers per day. So when I take the derivative of A, it's not 1, it's A prime. Now 0.3, when I take the derivative, normally it's 2/3, and someone specifically asked this question. There's a chain rule on that, right? So if this were U, it would be 2/3 times U, oh sorry, 1/3, U prime. Again, the reason there's a chain rule on that is the derivative isn't W, it's T. So when I take the derivative of W, you bring the power down, reduce the one, you have to think of a chain rule on this, and then think the derivative of what's inside, which is W prime. And then you just put all the numbers in. 0.3 times 2/3 times 125, 1/3. And they tell us that in the previous question, 0.7. No, crap, sorry. Attendance, 0.7 there. No, crap, hold on, I wanna make sure I'm doing this right. At 30, so I went for 0.5, sorry. So W prime is 0.5. W prime is 0.5. Now, here's the thing, on the quiz guide, or on the AP exam, leave it like this. Don't do the calculation. Leave it like that, I'm telling you. Now, that goes against any common sense, 0.02. But the exam will accept that answer, and you can only screw it up. Here, you can't get any more points by doing the calculation. So you're actually better off leaving it like that. Okay, that's number 3.